Hi, this is Dr. Behruz Fallahi from Department of Mechanical Engineering at Northern Illinois University. We have discussed the analysis of simple mechanism. They are a four-bar mechanism, a slider crank mechanism, and inverted slide crank mechanism type 1 and type 2. In this video, I would like to bring to your attention the mathematical structure that the loop equation of this simple mechanism reduced to. The reason that this concept is important is that when we are working on more complex mechanism, many of them can be reduced to one of these patterns, and therefore we can use the procedure that we discussed for the simple mechanism and apply it to the more complex mechanism. So now let's review what we have learned so far. This is the unknown of the problem, and on the left you see the vector loop with the vectors and the angles. Now here you see the vector loop equation for four-bar mechanism, and then we introduce a some vector and substitute it in the vector loop equation, and then we arrive at the reduced form of the vector loop equation. In this equation, the sum of three vectors, the algebraic sum of three vectors is 0. One vector, which is r, its length and angle is completely known. The other two vectors, the length are known, but the angles are unknown. Then we discuss how we solve such an equation for the two unknown angle. The next mechanism that we discuss is inverted slider crank mechanism type 1. Again, the list of the parameters that are given are listed here, and the unknowns are listed here. The loop equation is shown here in green, and the expression for the loop equation are shown here. Now, this by itself is a sum of three vectors, and in this vector, two of the vectors are completely known, and those are r2 and r1, but the length and the angle of the same vector are unknown, and that vector is r3. And then we discuss a procedure how to solve the angle and the length of this unknown vector. The next problem that we discussed is a slider crank mechanism. The vector loop equation are shown here, so if you go around the loop, you can write this vector equation. Again, if you introduce the sum vector r according to this expression and place it back, substitute it back in the vector loop equation, you come up with a reduced equation. Now, the characteristic of this equation is that one vector is completely known, and that's r, and the length of one vector and the angle of a second vector is unknown. In this equation, the length of vector r1 is unknown, and the angle of vector r3 is unknown. And again, we discuss this a procedure for how to solve for the unknown length and the unknown angle. Now, this is the fourth simple mechanism that we discussed. This is inverted slider crank mechanism type 2. The vector equation is reported here. If we introduce some vector and then substitute it in the vector loop equation, you are arriving at the simplified vector loop equation. in the simplified vector equation, R is completely known. That is, we know is we can compute its length and angle based on the data that are given. The length of the vector R3 is unknown. The angle of vector R3 are also unknown, and the angle of vector R4 is also unknown. However, there is a relationship between the angle of vector R3 and R4. That relationship is that R3 and R4 remains perpendicular at all times, and by all times I mean as the mechanism moves. Therefore, the angle of R4, which is designated by theta 4, will be the angle theta 3 plus 90 degrees. And we are going to, and as you have seen, we have used this relationship in order, in addition to the vector loop equation, in order to solve for all the unknowns of the inverted slider crank mechanism type 2. This concludes this video. And now the material that we discussed here will be useful in the analysis of multi-loop mechanism, which is the subject of next video.